Hello and welcome to 15.1 Day 2 Notes. We're simplifying radical expressions today that have higher than a square root index. So we're just going to go through as many examples as we have time for. So to do these problems, you just need to see what the index number is, and that tells you what group size you're looking for. So I'm looking for group size 3. So you're just going to break down whatever you have on the inside into all of its parts. So x cubed is really x times x times x, and you're just looking for groups of size 3. If you have 3 of the same item, it comes on the outside. If you have anything left over, it goes back inside the radical. But there's nothing here, so x cubed and the cube root of x cubed, those are inverse operations, so your answer is just x. Okay, x to the 5th, well that's x, broken down. Looking for groups of size 3, so I'm going to circle 3 of these, which means I'm bringing on the outside an x. Everything else is going to go back inside the radical with that same index. Make sure when you do this that that's a tiny little 3. If you forget the 3, you change it from a cube root to a square root, which is wrong. You have to keep that same index. So cube root, there are 2 x's left over, so that's going to go back in as x squared. Another way of doing this besides having to write this out is just say how many times does 3 go into 5? 3 goes into 5 one whole time, with the remainder of 2. So it's a little easier than having to write out every single x, especially if you have a whole bunch of them. All right, 128, we're just going to do a factor tree. 128, half of 128 is 64, half of 64 is 32, half of 32 is 16, half of 16 is 8, half of 8 is 4, and half of 4 is 2. So I have this 128 broken down completely. I'm looking for groups of size 3. So I'm just going to circle, and don't forget, you're never going to use the thing that has a branch off of it. So I'm never going to use these big numbers. I'm only going to use the ones at the end of the branch. So I'm going to pull out this group of size 3 and this group of size 3, and then this guy is just by himself. So on the outside, I'm going to pull out a 2 and another 2. Then on the inside, I'm stuck with a cube root. And then left over is just this number 2. And anything on the outside, you're going to multiply. If I had more than one thing on the inside, I would multiply. Kind of like here, x times x is x squared. So my answer, 2 times 2, is 4 cube root of 2. That's my final answer. All right, 3 more examples of these. Okay, again, starting over here, I now have numbers and variables. I'm just going to break everything down individually. Again, I'm looking for groups of size 3. 24, I like to break things down with 2s. It's a little easier. Half of 24 is 12. Half of 12 is 6. Half of 6 is 3. So I've got all my little tiny branches. I'm not going to use the 12 or the 6. All right, and then x to the 6th. You can actually write it out if you want to. I'm going to not do that on the ones that have larger numbers. We're just going to use the division shortcut. Okay, looking for groups of size 3. So I have 3 2s, and then I just have this little 3 by himself. So on the outside, I'm going to bring a 2. I'm going to skip some space for any variables I have, and I'm just going to go ahead and do my radical, and my index is 3. Left on the inside is just 3. So the cube root of 24 is 2 cube root 3. Pulled out a group of size 2. I'm sorry, I pulled out a group of 2s, and then I pulled out a 3. All right, x's. 2 ways to do it. The easier way is just to say 3 goes into 6 how many times perfectly? Well, 3 goes into 6 2 times. So I have 2 x's, and there's no remainder. If I actually look at the grouping, I have x there and an x there. Group size 3 pulls out 1x. And then a group of size 3 pulls out another x, so I have x squared on the outside, and that's my final answer. All right, this number 5 right here, I already have a little stuff on the outside, so just be mindful of that. But again, group size 3, so I'm going to break 54 down. Half of 54 is 27. 27 is 3 times 9. 9 is 3 times 3. Then y to the 4th is y. But again, we're going to do the shortcut, but you can write it out if you need to, but there might be some that have a lot, and there will be some on the back of this page. All right, so firstly, this y to the 6th is on the outside, so I'm just going to bring him straight down. So y to the 6th is not going anywhere. Okay, looking for groups of size 3, So 3 of the same number, so there's 3 3s here. So I'm just going to pull out a 3. This 2 does not have a partner, so he is stuck on the inside. Whenever I have variables, I always skip the same number of spaces as variables. Like this one has 3 variables, I'll skip a lot. This one only has 1, so I'm going to skip a little space. I'm going to go cube root, and then put this 2 back on the inside. Okay? Now variables. What you do is you ask yourself, how many times does this index go into the variable? How many times does 3 go into 4 evenly? It goes in perfectly 1 time with a remainder of 1. Because 3 times 1 is 3, plus 1 is 4. Also, if you broke it into groups, you'd pull out 1y, there's that guy, with 1 remainder. At the very end, just push everything together. I had 6 y's initially. I added an y to the group, so now I have 7 y's. And we always actually put the number out front. So I'm just going to go ahead and put 3y to the 7th, and then make sure very clearly cube root, and then on the inside is just 2y. All right, last one of these is this guy here. We have a 2 on the outside, looking for group size 3. I have a whole bunch of variables. I'm just going to break everything down individually. 125 is 5 times 25. 25 is 5 times 5. So my numbers are broken down. And I do not want to write down 7 A's and 9 B's and a C. So we're going to do the shortcut here, but if you really did want to write them all down, you could. But I'm just going to do the shortcut. All right, so first things first, this 2 on the outside needs to come straight down. Okay, looking at numbers, looking for groups of size 3. So I actually do have 125 as a perfect cube, so it's just a 5 with nothing on the inside. Then looking at variables, I'm going to say 3 goes into 7 how many times? Well, 3 times 2 is 6 with a remainder of 1. 3 goes into 7 2 full times, and I'm going to skip space for A, B, and C, and then go over here and do my cube root. So 3 goes into 7 2 whole times with 1 remainder. 3 times 2 is 6, plus 1 more, 7. Okay, then moving on to B. 3 goes into 9 3 whole times. 3 times 3 is 9. So 3 goes into 9 3 whole times with no remainder, so nothing goes on the inside. And then 3 goes into 1, not at all. 3 does not go into 1 at all because 1 is too small. 3 has to go into 3, 4, 5, 6, something like that. So 3 does not go into 1, so there's not enough C's, if I were to write it out, there's not enough C's to make a group of size 3, so this C just goes straight back inside, and that is your answer. Let's go ahead and clean it up a little bit. 2 times 5 is 10, A squared, B cubed. Don't forget your cube root. Make sure it's very clearly inside of there, and then A and C, and that guy is done. All right, moving on to the next examples. These are all going to be 4th root. So just whenever you're doing any square root, cube root, any root, just pay attention to this number here. But the process is exactly the same. So I'm looking for groups of size 4. So break down everything you know. 48, half of 48 is 24. Half of 24 is 12. Half of 12 is 6. Half of 6 is 3. Okay? Looking for groups of size 4. So again, ignore the ones that have branches off of them and just go find, I found 4 2's. So I'm going to take a 2 on the outside. I'm going to skip the space that I have for variables and just do my 4th root. Anything left over goes back on the inside. Okay, variable wise, I'll go ahead and write it out one time, but we're going to do the shortcut all the rest of the times. 4 goes into 6 how many times? Well, if you're counting by 4s, 4 goes into 6 one time because it goes into 8 twice. So 4 goes into 6 one whole time, which leaves 2 left over because 4 times 1 is 4 plus 2 more is 6. Or if you need to write it out, groups of size 4 brings out 1x, leaving 2 x's on the inside. Okay, if I have anything to multiply, I will, but everything's already pretty much isolated, so we're good to go. All right, this one, pay attention. It is now a 5th root, so I'm looking for groups of size 5. So 96, half of 96 is 48. Half of 48 is 24, half of 24 is 12, half of 12 is 6, half of 6 is 3. Looking for groups of size 5. 1, 2, 3, 4, 5 2's here. So on the outside, I'm bringing in 2. I'm going to skip space for my variable, I'm going to make sure I put the correct index there, 5 and 5. Okay, and on the inside, I'm left with just a 3. Okay, if you want to write out all 10 y's, so 1, 2, 3, 5, 6, 7, 8, 9, 10, you can, but 5 goes into 10 how many times? 2 whole times with no remainder. So these little dots represent y's, so there's 5 y's there, 5 y's there, so I can bring out a y and a y, so 2 y's, so y squared. Okay, nothing to multiply, so these guys are done, just leave it as is. All right, this one. 4th root, so half of 162 is 81. 81 is 9 times 9. 9 is 3 times 3. Both these branches do the same thing. Okay, looking for groups of size 4. So make sure you keep track of all of your little branches. I'm not going to use 81 or 9 or 9. So I have 4 3s. So I'm going to pull out a 3. I'm going to skip space for my x, whatever index I normally have, leaving me a 2 on the inside. Okay, then if you wanted to write out 16x's, you can, but I'm going to say 4 goes into 16 how many times? Or if you do 16 divided by 4, how many times? Well, 4 times 4 is 16, and it's exactly, so there's no remainder. If this were a 17, I would say 4 goes into 17 4 times with 1 remainder, but this is perfect as is. So this guy is done. All right, our next one is a 6th root, okay? It just means you're going to have to break it down a bunch. Half of 192 is 96. Half of 96 is 48. Half of 48 is 24. Half of 24 is 12. Half of 12 is 6. Half of 6 is 3. Looking for groups of size 6. So 1, 2, 3, 4, 5, 6. So all of my 2's. But don't forget I have this 4 on the outside, so I'm just going to bring this 4 straight down. And now I pulled out a group of 2's. I'm going to skip space for A and B, so skip, skip. I'm going to put my 6th root, and I'm going to say I have a 3 left on the inside. Okay, 6 goes into 7 1 whole time with 1 remainder. 6 goes into 12 2 whole times with no remainder. Now I'm just going to clean it up a little bit. 4 times 2 is 8. A, B squared. Leave a good amount of space so you can see your index. And 3A. And you're done. All right, over here, again, I got a 2 on the outside, so be mindful of him, but I'm looking for groups of size 4. 486. That's 2. I'm looking at my answer here because this one I don't know in my head. 243 is 3 times 81. 81 is 9 times 9. 9 is 3 times 3. And 3 times 3. Looking for groups of size 4. So I'm going to pull out, not any of these guys, I'm going to pull out these 3's here. So a 2 on the outside already. Pulled out these 3's. Skipping space for the y, 4th root. That leaves me a 2 and a 3 on the inside. Just multiply them together, you get a 6. Okay, and I'm done with the numbers. Now variables. 4 goes into 7 1 whole time with 3 left over. And that's it. Clean it up, 6y, 4th root, 6y cubed. All right, last 2 are pretty easy. When you're looking for the index of size n, it only works for things that have an n on the inside. So this is saying I have n 9, so I have a whole bunch of 9s. I have n of them, so I can pull out a 9. How many times does n go into n? Well, it goes in 1 whole time, so I can pull out 1 number with no remainder. Okay, so this one's a little tricky. Just be mindful that n goes into n 1 time, n doesn't go into anything else. All right, so this last one here, you're going to multiply the insides. So 5 times 3 is 15. 2 and 4 give me a 6. N, there's a 1 here. N doesn't go into 1, and n doesn't go into 6, so you literally can't do anything. N only works when there's an n on the inside. So I'm just going to make up an example real quick. Nth root of x to the n y squared. Well, the n would work here, so I could pull out this x, but I could never pull out anything that does not have an n as an exponent. Okay, so this one's a little tricky. You won't see it very often, but if you ever have an n exponent, it only can bring out things that actually have an n exponent attached to it. So it just pulls out that 9. It just pulls out that x. Everything else is just left over. Alrighty, have a good day.